We're honored today to have Dale Chayes with us. Some of you know Dale for a while. I don't think anybody knows Dale as long as I've known him, since 1973.
Nobody I recognize here.
We first went to sea together in 1973 in Pittsburgh. How many people were born?
Come on, Jim, you can
I have to admit it.
And at that time, Dale was just 74.
74.
74.
It's almost the same as
At that time, Dale was just kind of finishing up, basically, or maybe you still were, being kind of the right-hand man for Bruce Eason, one of the real founders of marine geology. Somebody that Jim worked with for years, too.
a true character.
Really, quite, that's true, a true character in this business. And Dale, basically, through the years, you've always been at Lamont, I guess, all the time, even back then.
I went to Lamont for a summer job in 1973 when I graduated. It was a brief stop on my way to the University of North Dakota to become a Pleistocene geologist.
I never got there. So he's been up
Still there
ever since, starting as what he described his job on that first cruise as a rope choker, as opposed to these guys who are kind of writing code. We had two kinds of people on the ship: the rope chokers, the people who tied the knots and made all the things work, and then what was the contract?
Ohms. Actually, terminology from cable laying, cable repair ships. There's rope chokers and ohms.
OHMS, that's electrical stuff. So they're. And but Dale was always a very, very competent rope choker, and became an ohm too at the same time. a very competent ohm also, and has grown up to be a senior research engineer at Lamont, and has been responsible for the development of a number of different intriguing exotic systems and applications. CMARC, strong part of that, deeply towed or not so deeply towed Sidescan that was used in many adventures. And one of the most notorious episodes that Dale was involved in was the development of a mapping system, a swath mapping system that was put on a U.S. nuclear submarine.
Oh, I thought you were going to tell about how we got served a warrant by VHF radio.
Well, that's a different thing.
That's a different kind of notoriety.
And that's what I'm
It's true. Thank you for that nice invitation. I'm not sure I deserved all of it, but I got what I got. I'm going to talk about what I consider to be one of the coolest things I've been involved in a long time. Although I've been involved in lots of strange things. So in a sort of short sense, I'm going to talk about the SCICEX program as it was in the 90s. So in a sense, there's some history here. There's some interesting lessons here. I don't think the 90s was so long ago, but.
Well, and if I can just add a comment about relevancy, that just last week, the SCICEX science team met again. So so everything Dale's describing now, there's real thought of revitalizing it again.
Yeah, on the last slide, there'll be a link to where SCICEX is now. But we got to get through a couple of slides. I'll talk mostly about this system that I did most of the social engineering and some of the real engineering to get put together and on submarines and operated. In local context, this program is where we sucked Val into this business. Val was an officer on the submarine that we were allowed to use. I'm not going to talk much about data, but I'll provide a quick look. So SCICEX, the U.S. Navy, in order to sort of maintain competence and operational expertise, during the Cold War, routinely operated nuclear submarines in the Arctic of this particular class that we're going to talk about. The SCICEX that we're talking about here was a series of cruises that were dedicated to doing science on nuclear submarines. And there's a zapper right here. There was a cruise in '93, which we'll talk a little bit about, and then there was a series of 5 cruises. The '93 cruise was put together on pretty short notice as a sort of blind date proof of concept. And I got drafted into that project because I was the only person in our lab who knew about marine gravimeters and had a clearance, could go install it on the submarine on a few days' notice. So the other 5 cruises were done under a formal memorandum of agreement. And that's what most of the SCICEX program in what's now sometimes referred to as phase 1 or the original SCICEX memorandum of agreement. So each of those cruises involved a dozen or more science programs with principal investigators, mostly funded by NSF, executed by a very small number of science team riders or participants on the submarine, typically 4 or so. So we had this collection of cruises on a bunch of different submarines. We were very fortunate to be able to use the HAWKBILL 2 years in a row, and that's the submarine that we actually put the swath mapping system on. Each of the cruises is typically 30 to 40 days in this particular area in the Arctic, which different people have a different opinion about, but both of the people who matter's last names begin with G, so piss off the one who was most sensitive, we just referred to it as the G box. One of the things to bear in mind when you find the globe, go look at where the Arctic is and recognize that these classes of submarines are homeported in Pearl Harbor and New London. It's a long way by sea into the Arctic from either of those places. So there's typically, in addition to 30 or 40 days at work, another 20 days of transit. And the unclassifiedness and the G-box and a bunch of protocols are in a very formal memorandum of agreement, an MOA. One of the first things I learned in this project was that an MOA is real different than an MOU, a Memorandum of Understanding. As part of the SCAMP installation, I orchestrated the signing of a memorandum of agreement, which crossed the boundaries of 8 United States Navy admirals and was down to the level of detail about who provides the paintbrushes, who provides the paint, who cleans up the hazmat afterwards. Pretty complicated, a lot of details to get there. So when we first started learning in the blind date cruise in '93, we discovered that the Navy, has a standard way of doing virtually everything that they do. And as part of the protocol for taking a 637 class attack submarine to the Arctic, a piece of the Navy called the Arctic Submarine Lab outfits the submarine with a bunch of standard things that go on a U.S. Navy submarine of this class every time they go to the Arctic. And some things that are there all the time. Submarines have a narrow beam, downward looking sounder, which they really don't like to use because submarines are supposed to be quiet. And that was the first big disresonance between an active sonar mapping cruise and a culture that has spent 40 years trying to figure out how to be quiet in the ocean. We really want to go out and make noise all the time. Regular, repeatable, predictable noise that anybody could track. That was, but the Navy, having committed, the Navy got over a whole bunch of things that they would normally not do. Submarines are typically equipped with a Klein side scan, turned upside down, looking up, that they principally use for finding places where they could surface through the ice. The video camera, we'll see some data from some examples from both of them. They launch, so submarines have this capability of launching these probes or signaling devices, and there's a version of expendable CTD sensors that go out that launcher, and they come with a lot of baggage, but they work. There's a very arcane wonderfully old style interface to the ship's own data, the position and heading and depth. That's all encoded as synchro signals. And a Navy lab developed ice profiler, also intended to understand how thick the ice cover is, because the submarines have a limited capability for breaking through the ice. There's a picture here from the upward-looking video camera. That's the video scan lines just shot off the screen. And the important take-home message is that the Arctic sea ice is not uniform. There are places where you can go for kilometers and see uniform sea ice, but most of it is broken up and jumbled. Even from the surface, it looks pretty uniform. The light penetration makes it really clear there's lots of inhomogeneities there. And another, also a screenshot from upward-looking Klein 5000, I think, of a very early vintage. As part of the augmented science equipment that grew out of the SCICEX program, were a pair of classic Seabird CTDs installed in the sail with access to seawater, a deck winch. A number of the science programs that were looking for data in the Arctic were looking for a classic hydrography in the water sense, not hydrography in the depth of water sense. It's an interesting misused word, widely misused word in the ocean science community. So they designed this very elaborate structure. There's a little winch over here on the deck and a shiv, and you can see little Niskin bottles hanging down there. The deck winch was used in '98, and we came eventually to understand what an incredible waste of time it is to use this really cool asset to pretend it's a surface ship in the Arctic. It takes a huge amount of time to find a surfaceable feature sometimes. It takes a long time to surface. Submarines are not really very comfortable surfaced in open water in the ice. Among other things, the thing in the back that you or I would call a propeller and they call a propulsor is pretty fragile. And there's only one, so bumping into the ice with it's really a bad idea. And a fascinating, beautiful little winch that does in fact fit out the hatch over here in the background, and that's
If you want to know how dorky submariners are, those guys are playing chess in the foreground there in the ice.
That's one of the things I found really fascinating. I've been on a bunch of submarine cruises, been on lots of icebreaker cruises. Every once in a while there's an opportunity for people to get out on the ice, and it fascinates me what people choose to do. You know, they drive golf balls, they smoke cigars, they play soccer, they play football, they play frisbee. These guys spent hours sitting out there playing chess. I just thought that was of all of the crummy. This was taken with a state-of-the-art digital camera in that era. I bought a new digital camera for this cruise. Old Sony CyberShot that wrote on floppy disks.
Yeah.
Oh God, 640 by 40. Yeah. Had lots of requests for the high-resolution version of this picture. That's all there is. It's just like crap. The science community brought some additional push for instrumentation. The early one I mentioned that I put a gravimeter on in '93. In fact, we sailed a Bell BGM-3 marine gravimeter on all of the SCICEX cruises. A lot of interest in seawater samples for all kinds of classic ocean chemistry things. It turns out that in the place where there's room for science equipment, there was no standard way to get seawater. So in the first couple of cruises, sailors were grunting seawater from all the way through the submarine. and we eventually implemented an approved method of drawing water samples in the torpedo room. There was a very well-intended but not very successful desire to look at ocean currents with an ADCP. I don't have a good picture, but we cut a huge hole in the foredeck, under the free flood in the foredeck, and put an upward-looking ADCP on for 2 cruises, and the crummy navigation never produced anything useful out of it, which was unfortunate. So, not long after the '93 cruise, when this looked like the SCICEX program was going to go, I was accosted in the Lamont cafeteria, actually in the same way that I got roped into installing the gravity meter in '93. Mark Langseth and Bernie Coakley sat down with me in the Lamont cafeteria, and the first time around asked, actually Mark said, "You still have your security clearance?" And I said, "Yes." "Do it next week." And lo and behold, I'm taking a gravity meter to London. So we actually got together for lunch to talk about how that cruise had gone, and what would be the right approach for doing a routine, once a year gravity meter installation under the SCICEX memorandum. And we talked about that for a while, and then Mark said, approximately, can't you just Velcro on a modern suite of sonars? So this is in '93 or '94, when deep sea multibeams were becoming a common thing in the research fleet. And at that time and today, the Arctic is very poorly mapped. When we look at Martin's beautiful maps of the Arctic, it's important to remember that there's hardly any track lines there.
Yeah.
And in '93, there were far fewer track lines. So there's huge motivation to do this. After I choked on my sandwich, we fleshed out this concept, and because it's a history talk, I can mix the concept with the reality. You can't do anything in this world without an acronym, and I didn't think this one up. Most of somebody else, but there's the acronym. We actually installed and operated in '98, '99. We really wanted to put a multibeam on. In that era, nobody was prepared to build a multibeam with a small number of cables between the transducers and the inboard. There had been a plan. It's often referred to as the White Submarine proposition, in which there was a proposition to put a C-beam, multiple form beam echo sounder that requires dozens of hull fittings, which turns out to cost more than the sonar itself. So we compromised on a phase measurer, a 12 kilohertz phase measurer. We used a very traditional subbottom profiler. We got ODEC to package for us. Well, they packaged part of it, and then we sawed it in half and repackaged it ourselves. A real-time interface to this arcane submarine data system, and the gravity meter. So this picture is a torpedo room. Looking forward, this thing down here at the end is the place where you sit to launch torpedoes. Classic. So this is a history talk about things that happened in the middle '90s on a submarine that was commissioned in 1963. Something like that. Designed in the early '60s. Switches and relays and big neon glowing lights. Classic old-time technology, but incredibly reliable. And right over there is a torpedo tube, and there's another one over on this side. And these benches are just aluminum plates that are bolted down on the place where torpedoes would normally be stored. So the reality is, no, you can't do it with Velcro, but the Navy does have a pretty thoughtful but incredibly detailed process to get permission to do a temporary alteration. And well-defined, a pretty elaborate process that came out of the loss of a couple of early submarines. The Navy built this program called SubSafe, which is, in a lot of ways, pioneered industrial safety. One of the interesting reactions to Challenger fiasco was the Navy's participation in that review panel. Good grief, what are you guys doing? You don't have a safety program. It can be done, and it can be done if you find the right people to help, and that was an important clue. So we put together this sort of elaborate concept and rounded up the participants. So we're the lead organization in some of the science and the operational and technical part. Our lead partner was the U.S. Navy's Arctic Submarine Lab, which, in keeping with the way good federal bureaucracies work, is in San Diego. We invited the Hawaii Mapping Group to join this effort for two specific pieces. One, because they already had existing data processing capability for phase measuring side scans, and a world-class engineer, Mark Romstedt. Although when we started this, Bernie Coakley, who was one of our co-conspirators, was at Lamont. By the time this got rolling, Bernie was at Tulane, and before it was completed, he moved to the University of Alaska at Fairbanks. We had trained some folks from the Johns Hopkins Applied Physics Lab, who have a group of folks who routinely make modifications to the Navy submarines, and had once done something of this scale much more frequently, smaller things. A bunch of really motivated, competent folks that I'm still working with on other projects. They did a lot of the engineering and a lot of the detailed mechanical design. Some of the fab was done in their shop. A lot of the fab was contracted out, and they provided an enormous amount of installation help. They introduced us to the special projects folks at the Electric Boat Division of General Dynamics. That's the place you go when you want to hire somebody to weld on the pressure hull of a nuclear submarine. And it takes a lot of paperwork to do that. Raytheon, we had identified at the time we specified the 12 kilohertz phase measurer. We were intent on working with a group of folks who used to be at Alliant Tech Systems, and before that, International Submarine Technology. By the time this project came together, well, they were Alliant Tech Systems when it started. In between, they were a part of Hughes Aircraft, and by the time they delivered their part, they were a part of Raytheon. Ocean Data Equipment Corporation. So thinking about subbottom profilers, this predates the nicely packaged Knudsen's. So we did this today. We might use a Knudsen 3200 or a 320. Knudsen wasn't in that business in that era. So Bob Trini at ODEC worked with us for that. And probably the biggest, most important part of the way this played out was a bunch of very competent divers from Norfolk Naval Shipyard. All civilian divers. I've worked with a bunch of divers in the past, and I was impressed by these guys. They're of the 8 divers in the dive team, there were 9 in master's degrees. Yeah, not the normal stereotype of divers. When we were doing the installation and some remediation, they put 2 divers in the water at 6 o'clock in the morning with surface supplied air, and they worked till noon. And then they switched to 2 other divers in the water and worked till 6 p.m. really, really competent guys, and no whining, and you know, no dumb diver stuff, which is pretty impressive. So the in the approval process, we spent a lot of time on creating visuals. So to get this done, I mentioned that, you know, to get the MOA to do the work, we needed approval of a bunch of admirals. Long before that, we needed the buy-off from the same collection of admirals. And the way it was explained to me by our guide through this process, who was George Newton, at the time the chair of the Arctic Research Mission, any one of those 8 guys, and in that era they're all guys, could say no and stop it, but none of them could say yes and make it happen. So we spent almost a year visiting admirals and making our pitch to them. Part of that is this, you know, scaled, very realistic rendering of what a 637 submarine looks like, and how little and tiny the 2 bumps we want to stick on the outside are. So those are all to scale. That's the original plan we had in mind, to put the subbottom profiler and the swath mapper in a single pod, and the engineering and structural analysis made it clear that we couldn't take out that many blocks in a dry dock and leave that much of the hull unsuspended. So we ended up splitting it into 2 pieces. So this is a Pro-E rendering of the whole of the swath mapping pod, including the red things are shackles for rigging. It's modular. Each of these sections is 1 transducer, so there's 5 down each side. There's in the end 3 outboard pressure cases, which we managed to find a place above the waterline and put them under the free flood part of the hull. All 3 of these are jammed full of electronics. There's a simple checkout on this one is actually a checkout on my bench at Lamont. This one was a midnight re-engineering when the telemetry didn't work. done in a van on the pier at Pearl Harbor. That's Mark Romstad, still at UH, and Jay Ardai from Lamont, who's now happily retired and running a 1950s spinning mill in upstate New York. Been my co-conspirator in lots of entertaining events. He was the guy in the exposure suit in the couple of deck pictures I showed earlier. There's a rendering of the subbottom profiler showing 3. In the end, we had a 9 transducer array, but a similar pod construction. As installed in the submarine, very similar picture to the one we saw before. There's the torpedo panel. Here's all of our electronics down the side. It's a younger Val and Margot Edwards. Margot came out to sea with us for a week or 10 days in '99. The same event that Rita Caldwell came to sea with us for a weekend. It's pretty hard to go to sea for a weekend in the Arctic. I'll talk about that in a minute. So our original concept is to take the submarine in dry dock, put all the stuff on, you go out and go do the deed. Timing of funding and commitment of the submarine and approval plan made it clear we weren't going to get it, the pieces weren't going to come together that way. So we got an approval to do a phased installation where we met the submarine in an already scheduled dry dock in Pearl Harbor. And the simple way to think about it is we put some threaded inserts on the hull that we could bolt our pieces to, and we put in a couple of cable penetrators. And then we met the submarine a year later, approximately, dockside in Pearl Harbor, and did all of the equipment installation in the water. And that, having to do the in-water stuff really complicated the design process. And that's where the divers, having the divers involved at the design process was really a big step forward. So there's a threaded insert. There's the hull. And the piece that's welded on, and a bunch of alignment spacers, and a resilient mount going to our foundation. So there's so a lot of this was done as CAD, but a lot of it was drawn by hand, and the temp-alt package is actually a 3-ring binder full of drawings and calculations. So we, in our original installation plan, there was this cartoon that says, well, you know, the submarine is sitting here, and we'll put a camel in to press them out away from the pier a little bit, and we'll lower a big handling bracket with our little sonar stuck on it down next to the pier, and we'll use some chain falls and pull the thing up underneath the submarine and put the bolts in. And look pretty reasonable. So you start by building a gypsy camp out of, so there are 2 sea freight containers, modified sea freight containers here. One of them is the dive shop, which has got all the compressors and all the dive gear, and the other was a container of mine that we had modified to be a workshop and a lab, and the shipping container, if you will, or the shipping box, if you will, for all the sonars. That's the frame, this big thing here assembled on the pier. That's a foundation for the subbottom profiler. And in fact, over here we're assembling the swath mapper with our rented crane. And this picture is taken from standing up on the sail on the submarine. If you look closely, there's the whole of the swath mapper sitting on the frame, getting ready to get picked up. Tip it up sideways with a really good rigger that came with the crane operator from Pier Services in Pearl Harbor. And the giant snots of cables that we end up hooking up. You lower it into the water next to the pier. There's the diver, one of the 2 divers. And swing it underneath the submarine. So we did take it to the Arctic. Here's a for sort of contemplation purposes, our Arctic with all of the existing Healy tracks till 2010. That's right. This is the Amore cruise to the Gapple Ridge, which happened because we found active volcanism in 98, 99. So in the same reference frame, there's where the Fargo went in 93 in less than 20 days. And the Kavala in 95. Hoagie in 96. Archerfish in 97. Hawkbill in 98. So this is the first year with the swath mapper on, and it was a mixed bag. This was an intentional survey at the Gapple. This was a site survey for the ocean drilling program for the looking at one of the potential sites for the hole that was eventually drilled. This was a stumbling around attempt to try and find a front, really not very well conceived experiment in trying to use the submarine to map circulation features in the Arctic. And 99, pretty much dedicated to SCAMP and the Swath Mapper. So at the same sort of line width and spacing as what the Healy's done in 10 years in the Arctic, we did in 5 cruises. I'm gonna add the Huey in there, you can see where we went. So, first evidence of active volcanic activity in the DAQCS from the 98 cruise. Arguably a new deepest location in the Arctic, although some folks claim the Malloy Deep was actually deeper. Lots of ice draft data in ocean circulation. So there's a couple of pictures of Swath Bathymetry data at the DAQCS. There's the Sidescan image data from SCAMP showing the fresh bathymetry. Really nice subbottom data from a very low power, simple subbottom profiler because the submarine's so quiet and is a very stable platform. So in '99, the Navy ran a huge public relations program out of an ice camp in the Beaufort Sea that had a couple of different parts. So we went, I'm going to count on my fingers and use my memory. Went to the ice camp 3 times. First time we went there, we picked up Terry Whitlet, I think, and a couple of reporters, and we took them out for a week. We came back and dropped them off, picked up Margot and some other reporters. There was a CNN camera crew, there was a writer from the Christian Science Monitor, there was a camera crew from, it was sponsored by GBH, public television, and as far as I know, nothing ever came of that. It was a nice
Geographic was the other
Yes,
one.
so it was a National Geographic writer and a photographer, and they did a nice article in the Arctic that had a couple of submarine pictures in it. Amazing the amount of work they go to put 2 pictures in a magazine article. There are a bunch of press opportunities. This is the first time that PIs got to get on the submarine for a week and get off. All of the previous events, you get on at the beginning with the crew and get off at the end. And they at the last, I guess there were 4 visits, because we came and picked up, we picked up a bunch of distinguished visitors for an overnight event. Just can imagine this for a minute. The wear and tear of flying from DC on a Thursday night and flying them up to Dead Horse and picking them up on a plane and bringing them out to an ice camp on Saturday morning and stuffing them down the hatch in the submarine and touring them around the submarine and then stuffing them full of food and putting them to bed and then boosting them out the next morning.
The Admiral of the Pacific Fleet, Big Al the Sailor's pal, lost his luggage on that trip and bought 3 pairs of underwear for $90 in Barrow, Alaska.
And he's featured in the CNN video as explaining how much it cost him. He was a hoot. Really, a very interesting collection of folks. I think we'll see some pictures of them in a minute. But the sort of sideshow. So we know that there's an ice camp up there on the surface with people and some buildings, and they've got an underwater telephone, and we're talking to them. And I was sort of intrigued about how you, having spent a bunch of time on submarines, looking at the upward-looking swath mapper and the ice profiler and trying to find a place to surface. But in this movie, you got to surface close enough so in a snowmobile or walking you can get back and forth to the camp. So you find the right kind of piece of ice, you drill some holes in it, figure out it's the right thickness, and you put an X on the ice. Perfect sense, right? And then the submarine comes underneath. Look at that. And in the upward looking camera, there's the X.
Who figured that out? That's pretty clever.
You know, if you scrape off a little bit of the snow on a smooth piece of ice, you get a lot more light through it. And I was quite amused by this.
They also lowered a strobe, which I don't know if it's in that picture or not. They might have pulled the strobe by then.
Yeah.
Both an acoustic one, but
An optical one.
An optical one.
To see with the periscope, I guess, because there aren't even,
Yeah.
at least there aren't any windows in the part that I got to see. So we converted this to PowerPoint at the last minute, so you don't get to see this cool movie. But trust me, there used to be a cool movie. If you know where the submarine's going to surface, then you can set up a camera and take pictures. So there's a couple of pictures of the ice camp and a twin otter on wheels to get people in and out. And our collection of dazed and confused visitors. So you know, on top of all of the abuse of schlepping them across the country and across Alaska and stuffing them in a twin otter and bringing them out, you stick them on a bunch of sleds facing backwards and scare them to this big thing sticking up, and they say, "Go down a hole." And they're so there's this sort of culture gap. You know, the kids are out here with the pickaxes in the ice making this hole. Are all in their early, late teens, early 20s, and if you told them to, would dive down that hole head first. And I kept saying, these are congressmen and senators and smart, pleasant 60-year-old ladies we're going to ask to climb down this ladder. But it worked. So they stuck them in the submarine. That's where the camp was. The barrel was down here. And I don't remember all these guys. That guy's John Hamray, who at the time was the Deputy Secretary of Defense for Research and Development. That's his assistant. Somewhere his wife came along. That's Rita Caldwell, who at the time was the director of the Science Foundation. That's Jay Johnston? A couple of 4-star admirals. That's Jim Bastiani.
Konetsky.
What's that? Oh, oh, that's right. It's Konetsky.
Yeah.
Jim Bastiani is from a previous. He was the OIC of the NR1 when I was working with the NR1.
I'm not sure if they put all those guys in our staterooms and officer staterooms and bumped us out to other places, and the Secretary of the Navy didn't like sleeping in the coffin of space that you get to sleep in, and so he crawled out on the floor, and the Deputy Secretary of Defense got out of his rack on the top and landed right on top of the
Stepped on him. And another one had some back problems and decided he was going to go find a chair to sleep in, which is where the chief of the boat had intended to sleep. But there's another wonderful snippet in the CNN video, which is out on the web somewhere, of Captain Perry, the CEO of the submarine, in the chief's mess with all the chiefs just before, going through the final plan just before we surfaced, explaining that, on the clip you don't hear it all, but he'd gone through all the sequence of events and who's doing what, who's sleeping where. And the line that really struck me is, is summaries. And so, all they have to do is stand on our heads for 24 hours and then they'll be gone and we come back to work. So here's my summary slide. It really can be done. The rules in that era were complicated. They're much more complicated now. But we know lots more now. We can do it again. Submarines, as it's no surprise, they're incredibly stable. They're stunningly acoustically quiet. Even compared to surface ships and big surface ships in nice weather, they're still more stable. But they go really fast. I lied about the 20 knots. Notice there was sort of an approximately 20 knots. I think, you know, with enough, we had a speed limit because there were some concerns about high-speed maneuverability with the giant pods on the bottom. So one interpretation of that is they were trying to shake down the Science Foundation for another $500,000 for some elaborate analysis that nobody had ever done before. My program manager said, no, not going to do that. So we were limited to 18 knots. But you know, for those of us who spent days bashing around on the ice and still not get to go where you want to go, being able to go 18 knots in a straight line is really a wonderful way to survey. Works great for underway survey. It's a stunningly inefficient platform to try and use as a surface ship. It's really hard to schedule the resources. A lot of people have said, you know, what's it like to be there, to go? It's the coolest thing in the world, but you really got to want to be there. It's not a circumstance you want to find yourself in and have second thoughts about you really want to be there. So, you know, only the totally deluded would think that, you know, this is something I did by myself. It's the work of lots of people. Some of whom are named here and many of whom aren't. Most of the funding came from the National Science Foundation. The Subbottom Profiler was funded by the Palisades Geophysical Institute and the Norwegian Petroleum Director. We had a little bit of cost share money to do the original concept design. Lots of good support from the Arctic Submarine Lab, and the thing that really impressed me was how deeply committed the U.S. Navy was to make this happen after they bought into it. So we spent, you know, 2 years, a huge amount of money and time and effort getting up to the day where we sailed out of Pearl Harbor and headed north. And we got up to the vicinity of St. Lawrence Island and the Bering Straits, and the nav system stopped working. And I thought, well, I guess we're done. And we went to, you know, we turned around and went to Bangor, Washington, so it's a week and a half to get up to St. Lawrence Island, and almost a week and a half to get to this Navy base in Bangor, Washington. Spent a week there while a guy with a little hammer beat on the inertial nav system. Literally. We got back in the submarine, we went back up virtually, as far as I can tell, virtually the same thing happened when we got, it's the place where you change the nav system over to polar mode and stop working. Now what? So we went back to Pearl Harbor. It's the same, it's virtually the same distance. Spent another week in Pearl Harbor where they came with a different hammer, I guess. And we went back again. You know, no surface ship cruise I know that's had those kinds of things happen. You know, we dropped one of our science writers because he had we were supposed to be at the North Pole on the 4th of July. And at the end of August, he couldn't sustain this anymore because he had to go start a teaching job. But in the end, we went to the Arctic and ran our program. So interestingly, this whole program was done long before the current models of data stewardship were in place. We are working pretty hard at trying to recover lots of the bits and pieces of data and metadata and historical documents, and that's where they're going. So there's a fair amount of content there, and there's more growing there. I'm happy to answer questions.
Dale, you mentioned how awesome it is as a survey platform, and then shortly after you mentioned navigation issues. How good is the navigation compared to surface ship?
By modern standards, it's terrible. You know, we assume that a $200 GPS receiver is going to get us position accuracy of 10 meters or 20 meters. And, you know, if you pay a few more orders of magnitude than that, you can do, you know, another order of magnitude better. The inertial nav system on these submarines can generate errors of kilometer scale or more over a couple of weeks. And historically, there hasn't been a really good way to get a handle on that. But once you can make swath bathymetry and convince people that the seafloor is not changing in the time scale of a few days, you know, these huge features we're mapping, there was a lot of discussion. Part of the one piece of the discussion I sat in was with a bunch of very smart inertial nav guys who said, well, you know, if you just operate where the gravity anomalies are well understood, we can take them out. Well, you know, if we understood the gravity anomalies, we would have to go there and back. And it's this sort of amusing back and forth. They said, well, how about, why don't you go work in places where there aren't any gravity anomalies? Because no scientist I know is interested in those gravity anomalies. They're all flat. Okay.
Kind of a follow-up to Roland's, because I actually had the same question. Because I noticed when you showed your track lines that there's kind of pretty periodic jogs in all the track lines. Is that an artifact of the navigation and when you were actually getting absolute position fixes?
No, some of those are where we break off driving a line to surface. Some of them are where we break off to take water samples. So we, in lieu of surfacing and putting out CTV rosette, we developed this protocol for spiraling down as deep as our unclassified window allows us to go, and taking water samples through our valve through the pressure hull. Those tracks don't, the crude tracks at that scale don't have any nav adjustment in them. And you know, at the scale of that chart, the uncertainty in the nav is sort of the width of a fat line.
Did you leave the equipment on each of the submarines, or did you take it off and put it on the next submarine?
Part of the agonizingly detailed memorandum of agreement is the requirement that we restore the submarine back to its original, you know, so all those holes we cut in the hull have to be welded up and x-rayed and repainted, and so we did that for all of the submarines except the HAWKBILL. Part of the strategy, but Navy cut us a break and allowed us to use the same submarine twice, HAWKBILL in 98, 99. Partly, you know, because we were begging, you know, look at the enormous amount of money it cost to put this stuff on. So Navy allowed us to leave it on, which was quite unusual. And because the HAWKBILL was going to the razor blade factory, we didn't actually have to execute the restoration, but the plan for the restoration is there, or was there.
What type of swath width did you get in surveying? How did it compare with multi-beam of the same frequency at the same time?
From my perspective, the appropriate comparison, since it's a phase measure, the appropriate comparison would be to Gloria or to HMR1, another 10 or 12 kilohertz phase measure. And so swath widths are significantly wider, because I think because it's very quiet. 20 plus kilometers sort of routinely for image data. And the number that I think about a lot in thinking about the comparison between multi-beams and phase measurers is a long track, or if you will, in the multi-beam world, a long beam repeatability. So So if we go to some boring piece of the seafloor where there's, you know, sediment, or we look at a statistically huge sample, and look at the reported depth differences at some angular offset, we would expect on a flat seafloor for those differences to be a reasonable, the statistical characteristic of those differences to tell us something about the repeatability of the sonar. So we can't have an absolute measure, but we know from looking at a lot of MR1 and HMRG and CMARC2 data that repeatability for phase measures might be 0.5% of the water depth, sort of on par with first generation deep sea multibeams. And our swath data is about 0.2 or 0.3%, significantly better than what we expected. But you know, a good modern deep sea multibeam is 0.1% or 0.5%. Not, you know, better than we get with a phase measure. But I was really pleased with the performance. We put a fair amount of effort into designing the arrays to have a big notch at the 0 to plus 10 degrees, where we would expect to get returns from the underside of the ice canopy. But we were still able to do a pretty decent job at mapping ice canopy, even with and trying to reduce the impact of them. So I think that's a contributor to the phase errors. There's coherent reflectors out there that are in the wrong plane.
And, you know, I'm not technically adept on this. I don't know what a phase measure is. Is that the same thing as the interferometric system?
Yes.
Okay.
So there's 2 rows or 3 rows, and
okay.
in our case there are 4 rows of transducers, but we used a simple weighting mechanism to create, use the upper 3 and the lower 3 to create two synthetic rows and compare the phase difference between them.
We have some questions from the virtual audience.
The virtual audience.
Rob Evans would like to know if you foresee AUVs ever performing a broadly similar mission in the future.
I actually made a soapbox pitch a long time ago for what I consider to be big AUVs. So I think there's a within reach approach that says you build an AUV that's, you know, the size of a small school bus or an 18-passenger van and has the reach to drive across the Arctic and carry arrays of this size. In most of the world, auto sub and the big Monterey AUVs and bluefins are considered to be big AUVs, and none of them have anywhere near the physical size to carry 12 kilohertz arrays and a gravity meter, for instance.
We worked with the Canadian one, some of the IZ one does have that size.
It has the length.
Yeah, it doesn't have the array on it, but it has.
I'm not sure it has the payload, and it's an order of magnitude short of range. You know, it's very cool that it can go 150 clicks, but that doesn't get you very far when you're going across the Arctic.
Okay. And then Kurt is wondering if new U.S. Navy submarines have any plans to build bathymetric mapping systems onto their submarines.
I don't know any details. I know that they've expressed some interest. And Kurt, we want to know what the Band-Aids were for.
It was a Google bike accident, he told me.
We want the gory details.
Laugh out loud.
the Navy has done some thinking about using existing array capability to do mapping. That's the limit of what I know about it.
Are there any,
Is that it? Be hard.
are there any plans for you to do any more expeditions with?
I'd go tomorrow if somebody would commit a submarine. There's a couple of real issues. The big one is committing a submarine. If you talk to the folks who do sort of long-term scheduling of using submarines, they show you this big list of requests and the little list of submarine deployment days or weeks or months or years, and the science request is down there, at the bottom of their priority list. I'd love to figure out how to get it higher up.
I can report on the result of this last CCICEX meeting, where there's tremendous enthusiasm on part of some parts of the Navy. The oceanographer of the Navy is very enthusiastic about this, and there's something called the Navy Arctic Roadmap, which outlines a renewed SCICEX and mapping capability. And it ran into, I'm going to call it a virtual, absolute brick wall with N87, with the real part of the Navy. Just said no. And so this is what always happens, and so it just
until there's
their response was, "What's in it for us?"
Yep.
And somebody's going to have to convince them of that, because they control the.
Yeah. So the way SCICEX in its first incarnation got access is the top of the U.S. federal government said this is a very high priority, and that will isn't there. It's got to become more important than all the other cool things you can do with attack submarines. Anybody else?
Well, thank you very much.
Thank you.